Hello, my name is Ray Biggerstaff, and today I am going to go over an example of a related rates problem, more or less to teach related rates. Rather, I prefer to demonstrate one of my favorite things about mathematics. That is, within mathematics, even though we have to obey certain rules and postulates and theorems, there is still room within those rules to pick and choose the way in which we prefer to solve a problem. Let me give an example of this using algebra. Let's say we have the example 3 times x minus 2 equals 6. Of course, we have the algebraic rule that we can't disobey no matter what, that what you do to one side of the equation you must do to the other. But as long as you're doing that, there's freedom to choose 2 different ways you want to solve this problem. I could distribute the 3x minus 6 equals 6, add 6 to both sides, and then divide by 3, which would give us 4. Here, I could just skip the distribution altogether, divide both sides by 3, and then add 2. Right? Whether we do it that way or that way, as long as we do it correctly and abide by the rules that we chose to use, we'll get the right answer. What do I do with my eraser? There we go. Okay. Alright, good. So one of my students recently gave me a related rates problem, and they asked if it was possible to solve the problem without using the product rule when it came to deriving the equation we were using. And at first I didn't think it was possible, but after a little extra thought, I figured it out, and it was quite exciting. So the problem asks, given a right cylinder, at what rate is the volume changing, so dV dt, if the radius is changing at a rate of, it's increasing at a rate of 2 inches per minute, and the height is decreasing at a rate of 3 inches per minute, so it's decreasing, we do a -3, when the radius equals 8 and the height equals 12. Alright, so how we're going to relate the variables we have in this problem, volume, radius, and height, is using the volume formula for a cylinder, so pi r squared h. Now we're looking for dV dt, so we must derive this equation with respect to t. dV dt equals pi times, now here, because we have 2 variables, r and h, we have to use the product rule. So r squared dh dt plus 2r dr dth. Now we have everything we need. We have r, we have dh dt, we have r, and we have dr dt. So at this point, all you have to do is plug in your values and simplify. Now, just for the sake of time, I'm not going to do all that. We would end up with 192 pi is the rate at which the volume is changing. But let's say you absolutely despise the product rule. You just did not want to do it. There is another way you can solve this problem. Now, it's a little bit longer, but let's say you don't care. You just don't want to use the product rule. We could avoid the product rule by only having one variable, which means we'd either have to substitute h in for r or r in for h. We'd have to establish a relationship between the two of them. So let's figure out what kind of relationship do r and h have in this problem. If we look, every minute the radius increases by 2, and every minute the height decreases by 3. So that would suggest a linear relationship. We should be familiar with y equals mx plus b, a way in which we can describe a linear relationship. Here we're not dealing with x and y, we're dealing with h and r. I'm going to go ahead and put have this equation solved for r, for h, so h is dependent upon r. Alright, slope, let's see. Remember, slope is the change in the y-coordinate over the change in the x-coordinate, or here it's going to be the change in h over the change in r, which we have. The change in h is -3, and the change in r is 2. So this would be the slope of our linear relationship. And then we need to find b, the y-intercept, or in this case the h-intercept, if we were to graph this. We have a point. When r is 8, h is 12. So plug in 12 for h, 8 for r, and solve for b. 12 equals negative 24 over 2. So 12 equals negative 12. B equals 24. Good. All right. So we now have that h equals negative 3 halves r plus 24. All right. Back to our volume formula. B equals pi r squared h. We know now that h equals this, so let's go ahead and substitute that in for h. V equals pi r squared times negative 3 halves r plus 24. Good. Distribute the r. Pi times negative 3 halves r cubed plus 24r squared. Good. So now we have the volume of the cylinder with respect to only one variable, just its radius. Let's go ahead and derive that with respect to time. dv dt equals pi times negative 9 over 2 r squared dr dt plus 48r dr dt. Well, there we go. We did what we set out to do. We did not have to use the product rule when we derived the volume formula this time. In fact, we only had to use the power rule. Now, go ahead and plug in our values for r. So we have 8 for r and 2 for dr dt. Good. Yeah. If you simplify all that, I trust you can do that on your own, you will find that this indeed equals 192 pi. So we did get the same answer. So again, this was just to demonstrate that you can pick and choose the way in which you want to do the problem. I would recommend that you do this problem using the product rule. It's much shorter and much more efficient, especially since they gave you all the information you needed right off the bat. But again, if you absolutely hate the product rule, this is a way you can do it without using the product rule.